So in this session, we are going to discuss about how to derive the Jacobian of RP Manipulator. So we are going to use the formula method for deriving the Jacobian. So J is equal to J1, J2, etc. up to Jn. So if you have n joints, then this is the generalized form of your Jacobian matrix, and each column it is corresponds to each uh, joint in the manipulator, right? So the Jacobian, it has both linear Jacobian and angular Jacobian, and the formula for finding the linear Jacobian, for if it is a revolute joint and if it is a prismatic joint or different. So the linear Jacobian for revolute joint, it is Zi minus 1 in cross product. Okay, so this is cross product of Zi minus 1 and On minus Oi minus 1. And for prismatic joint, it is Zi minus 1. And the angular Jacobian for revolute joint, it is Zi minus 1. And for prismatic joint, it is 0. Now, this is the RP manipulator that we have considered. As you see, it has two joints, that is one is the revolute joint with the joint coordinate theta 1, and another one is the prismatic joint with the joint coordinate t2, right? So here we have to be cautious on when you just apply the formula, because it is not the both the joints, it's not of the same type. One is revolute and the other one is prismatic. So as you know, this we have to just determine the transformation matrices. So already we have derived the transformation matrices for RP manipulator when we just did the forward kinematic model. So I have just directly used here. So that is T1 to 0, the transformation matrix of the first frame related to the reference frame it is given, and also the transformation matrix of the second frame related to the first frame that is associated with the prismatic joint, that is also given. But what we want is we need to find the transformation matrix related to the we want the transformation matrix that is relating the second frame with the base frame itself, right? So that for that, how we'll get it? So just multiplying the two transformation matrix T1 to 0 and 2 to 1 will give you the transformation matrix of the second frame relating to the base frame, right? So from this, we can just get whatever we'll be using these two transformation matrices. So from the first transformation matrix, that is T1 to 0. So this is our O1, and this is our Z1. So this is our Z1, right? Likewise, from the transformation matrix T2 to 0, this is O2 and this is Z2. Right, so directly you can use this and substitute in the formula for Jacobian. That is, first we'll try to get the first column. So here in first column it relates to the revolute joint. So the formula goes with the cross product of Z0 and O2 minus O0 and Z0. So here you have, so this is your J linear Jacobian and this is your angular Jacobian part. So here Z0, it is always, as I told you earlier while deriving the RR manipulator Jacobian, I told you the Z0, it is always 0 to 0, 0, 1. Why it is 0, 0, 1? So it means the rotation of the zeroth frame with relative to itself, right? So it is 0, 0, 1. So cos 0, it is 1, so it is 0, 0, 1, right? And what about O0? O0, it is the position of the zeroth frame relative to itself. So the origin is same. So here O0, it will be 0, 0, 0. Okay. So from the transformation matrix T2 to 0, we have got the O2, right? So just substituting all here, you will be getting the cross product of 0, 0, 1 and D2S1 minus D2C1 0, right? And this is simply D2S1. Sorry, there is I think there is a mistake here. So this is Z0. So this should be 0 0 1. Okay. So this should be 0 0 1, right? So you'll be getting when you just do the cross product. So you this is this part, it is JV, and the bottom one, it is J omega, that is the angular Jacobian. So getting the cross product of these two matrices, it will give you this upper half. So here the to get the cross product, we need to multiply these two, 0 into 0 minus of 1 into minus D2C1. So you'll be getting plus D2C1. That is how you get the first element. And the second element, that is 0. I will use a different thing. So here 0 into 0, a minus of minus, because already you have a minus for the second row. So it is positive D2 S1. So here it is positive D2 S1. And the third one, it is simply 0. Okay, so that is you will be getting 0 here. So 0 0 1. So this is for J1, right? This is for J1. Similarly, you have to get for J2. For J2, the form, remember, it is the prismatic joint. So the J2 column corresponds to the prismatic joint. So the linear Jacobian, it is simply Z1, and the angular Jacobian is 0. So Z1 we have already found from the transformation matrix T1 to 0, which is simply S1 minus C1 0, right? So just combining J1 and J2, you will be getting the Jacobian matrix of the manipulator, which is represented as shown here.